Welcome everybody. Today we're going to be going over the basics of trigonometry, mostly sine, cosine, and tangent. Here I have a basic right triangle. I have the angles A and B selected, and I have capital A, B, and C side lengths. Learning about sine, cosine, and tangent wouldn't be complete without Sohcahtoa. No, this is not a word, this is an acronym. We can split this up into three parts: sine, cosine, and tangent. Starting with sine, the SO represents sine of x is equal to the opposite over the hypotenuse, where x is an angle. We will dive into further detail, but what this really means is that if I pick an angle, the sine of that angle is equal to the opposite side length divided by the hypotenuse side length. The definition of cosine is next. The CA in Sohcahtoa means that cosine of x is equal to the adjacent side length divided by the hypotenuse. Next we'll cover TOA, which means that tangent of x is equal to the opposite side length over the adjacent side length. These definitions are great and all, but it's best understood with an example. Here I've isolated angle B. Notice that the opposite side length is indeed the opposite of angle B. Likewise, the adjacent side length is the one that's always next to it. The hypotenuse is always the hypotenuse, no matter what angle you choose. If I take the sine of angle B, this is equivalent to taking the opposite side length, dividing it by the hypotenuse side length. Same thing goes for cosine, that is the adjacent divided by the hypotenuse, and tangent is the opposite over the adjacent. I've color-coded these so you can see exactly where on the triangle we are taking these values from. If we now focus on angle A, notice that the adjacent and the hypotenuse sides have switched. Instead, this bottom side is the opposite, and this one next to it is adjacent. Like I said earlier, the hypotenuse stays the same. The sine of angle A is the red opposite divided by the hypotenuse, its cosine is the blue adjacent divided by the hypotenuse, and its tangent is the red opposite divided by the blue adjacent. Notice that the red and blue colors have switched when we were considering angle B. Examples of numbers are nice. Here we have a very simple 3, 4, 5 triangle. This is one of the rare triangles with very nice side lengths. This makes it ideal to analyze sine, cosine, and tangent. Taking the sine of angle A, remember that it's the opposite over the hypotenuse. In this case, the opposite is 4, and the hypotenuse is 5. So our sine would be 4/5. Cosine of A, being the adjacent over the hypotenuse, is the same thing as 3/5. Lastly, tangent, opposite over adjacent, is 4/3. Put in decimal form, sine of A is 0.8, cosine of A is 0.6, and tangent of A is 1.33 continuous. There's one last important thing to discuss. Here I have the definitions of sine, cosine, and tangent again. What if I divide sine by cosine? If I write it shorthand, sine is O over h, or opposite over hypotenuse, and cosine is A over h, or adjacent over hypotenuse. Dividing sine by cosine gives us O over h divided by A over h. This is the same thing as O over h times h over A, or just O over A. Please excuse my shorthand. What this really means is that sine of x over cosine of x for some angle x is equal to the opposite over the adjacent. Recognize that this is the exact definition of tangent. In other words, tangent of x is equal to sine of x over cosine of x. I hope you learned a lot during this introduction for trigonometry. There's a lot more to discuss after this, but this covers the basics. Sine, cosine, and tangent play an integral role in geometry, calculus, and beyond. I hope all of this makes sense, and thank you very much.